Bright QT. Every student matters.
Hello dear students, the next topic we will be studying about is very important, and that is Ohm's law. Now in 1827 there was a physicist, a scientist whose name was George Simon Ohms. Now what did this Ohm said was, he gave a law known as Ohm's law, and this Ohm's law was basically a relationship between the potential difference and current in a particular circuit. What did Ohm's law tell us is, according to Ohm's law, at constant temperature, if the temperature is remained constant, at constant temperature, the current flowing through a conductor, any conducting wire or a conductor, is directly proportional to the potential difference across its ends. Now what do we mean by this particular law? According to Ohm's law, if we take a conducting wire, for example this is a wire having two ends A and B, then Ohm stated that the amount of current that is flowing through this conducting wire is basically directly proportional to the potential difference across its ends. Fine. So I can say that potential difference and current are directly proportional to each other, and I represent it by writing V, that is for potential difference. This alpha is the sign for directly proportional, and I is the symbol for current. So V alpha I or V is directly proportional to current. First of all students, you need to understand what do we mean by this particular word directly proportional and this symbol. If for example we are talking about two things, any two related things or unrelated things, we'll discuss now. If I put a sign of alpha between them, this means we read it like x is directly proportional to y, and the conclusion we draw from it is that if y changes, then there will be a direct effect in the same proportion on x. If y is increasing, x will also increase with the same proportion. If y is decreasing, x will also decrease with the same proportion. So the impact of a change in one side of this sign will directly impact the left hand or right hand side, the other side of the sign also. If two things are in numerator, like x and y are in numerator, and with the sign of this, we say that x and y are directly proportional to each other. Similarly, if I take both the things in denominator and I put a sign between them of the same alpha, directly proportional sign, this also means that they are directly proportional to each other. If one thing increases, the second thing will also increase. If one thing decreases, the second thing will also decrease in the same proportion. But please take care of this thing that I am telling you. If I put a sign of alpha and one value is a numerator and the other is a denominator, or vice versa, I can write 1 upon x, this sign, and y. This is denominator, this is numerator. If now one particular item is in numerator and other is in denominator and we have the same sign, then we say that now these two things are inversely proportional to each other. over here we said that they are directly proportional to each other. This concept you will be requiring later in this particular chapter, directly proportional and inversely proportional. Directly proportional when both the items were in numerator or in denominator having this sign. Inversely proportional when this sign is there but one is numerator and the another is denominator, then we say that they are inversely proportional. Means now when one thing increases, if y increases, then the inverse, the reciprocated effect will be found on x. If y is increasing, then x will decrease. Vice versa, if y is decreasing, x will increase. Same is the case here. They are inversely proportional because x is in denominator, y is in numerator. So if x increases, the reciprocal effect, y will decrease, and if x is decreasing, y will increase. Right? We can very simply understand the concept of directly proportional and inversely proportional with this particular example, that I say hard work is directly proportional to marks. The more you put in the hard work, the more marks you will get. So they are directly proportional to each other. Whereas mistakes are inversely proportional to marks. Means more will be the mistakes, less will be your marks. Less mistakes you will do in the examination, more marks will you obtain. So they are inversely proportional and directly proportional. I hope you have understood the concept. Now when coming back to Ohm's law, when I put this sign, I mean to say that V and I, the potential difference and the current in a particular circuit, they are directly proportional to each other. Means if the potential difference is more, then the current will be more, and vice versa. If the current is more, the potential difference will be more. If the current decreases, the value of potential difference will decrease, or vice versa. If the potential difference decreases, the current will also decrease. Fine. This is what Ohms said or concluded with his experiments. Fine. Now very importantly, another concept that you need to remember is, whenever we want to replace this directly proportional sign with an is equal to sign, you must be aware, otherwise please note it down, that whenever we convert a directly proportional sign into is equal sign, then what we need to do is, we need to multiply this one side with any constant value. And in this context, the constant value that we are taking is a capital R. Now this is what we deduce from Ohm's law, that V is equal to IR, where now what do these symbols mean? V stands for potential difference, right, which is also represented as PD. I represents current, and R is a constant, and like other constants, this constant also has a name. This is a constant called resistance. Now what is resistance? Right now, just to understand from this formula, resistance is a constant. Fine, it is a constant value. Fine. Now talking about the SI units, we know that the SI unit of potential difference is volt, which is represented by capital V. The SI unit of current is amperes, which is represented by capital A, and very importantly this resistance, the SI unit of resistance is ohms, by the name of Ohm. Who gave this law? Ohms. And this ohms is represented by this symbol, and this symbol actually in itself means omega, or it is called omega. So R is the resistance, and this resistance has an SI unit of ohms represented by this symbol omega. Got it? So this is Ohm's law. Now, when we said that in Ohm's law, we concluded that potential difference and current they are directly proportional to each other. In order to check it out, we can just confirm it with our own experience or our practical done in the laboratory. We can just check it out. How? Let us see. We will take this kind of a setup. What we have done over here is we have taken a circuit. In this, we had basically a battery consisting of these 4 individual cells. Fine. This is a plug key, as we know. This is an ammeter. This is a resistance. Fine. Now let us see what we exactly are trying to achieve. What we'll do is, first of all, we'll just connect this particular cell to this circuit. Connected it from here, right? This is the line coming up. I have connected a voltmeter across this resistance, which will measure the amount of potential difference, and I have joined or connected an ammeter, which will just measure the amount of current. So if I am putting up a single cell, I will switch it on, putting a dot. The current will flow from the positive terminal to the negative terminal. The arrows, of course, are very important. They are showing the direction. I will note down the reading of voltmeter and the ammeter, right? Then what will I do is, after noting down the reading, I will just take a battery of 2 cells now. Rather than taking a single cell, I'll be taking a battery of 2 cells. Fine. Once again, I'll switch on the circuit. Now again, I'll note down the reading of ammeter and voltmeter. Fine. Then I'll try it with taking 3 cells, again switching it on, taking the values, then with all the 4 cells, a battery of 4 cells, once again noting down the values. Now, after performing this experiment, I have taken number of cells 1, 2, 3 and 4. First of all, I'll see the ammeter reading, the current in the wire, I have noted down, and through voltmeter the potential difference. Fine. All the 4 readings I have taken up. Now, as per Ohm's law, what did Ohm's law tell me? Ohm's law stated that V is equal to IR. Actually, it was V is directly proportional to I, right? We just converted it like this and we got the value V is equal to IR. Fine. When I said that V is directly proportional to I, means I have explained by saying that if I is increasing, V will also increase, right? So now what I did was, in this experiment which I just did, I took the values of potential difference as well as current. Now what will I do is, I'll try to plot a graph based on these values. On one axis, I'll take the potential difference, on another axis, I'll take the current. Fine. You can take the opposite, you can take V here and I here, that is not material. Important thing is, now based on the values, when I will plot a graph between V and I, that is potential difference and current, importantly, I will always get a straight line. This straight line verifies Ohm's law. This straight line tells us that when V was increasing, I was also increasing and in the same proportion. That is why we have got a straight line. So this is a very important activity to verify Ohm's law. In the laboratory, we can have the setup of just arranging the electrical circuit with 1 cell, 2 cell, 3 cell and 4 cells with the same resistance, and then noting down the values of potential difference and ammeter and plotting the graph between V and I coming out to be a straight line shows that V is directly proportional to I. Got it? Fine. Now from this formula, V is equal to IR. What do I conclude? I can just manipulate this formula. I can also write I is equal to V upon R, taking R over here, or keeping R here only, I can also write, taking I here, I can write R is equal to V upon I. Now this is something important that we will be discussing in a bit of detail. Now what exactly this resistance is? Resistance, as we have till now understood, is it is a constant, right? But actually what exactly is resistance? Just try to relate. We know that every particular substance, whether it is a conducting wire or anything, any particular substance is made up of atoms, right? Fine. So these are the atoms, whether it is wood, whether it is anything, plastic, whether it is glass or anything. Any substance we see around us, matter, is made up of atoms. Fine. Now, when we talk about current, the current means the flow of electrons. So, when the electrons try to flow through this substance, these atoms of the particular elements, they try to restrict the flow of these electrons. This restriction, this opposition is known as resistance. In other words, in common layman terms, the atoms resist the flow of electrons, right? The more will be the resistance of the atoms, the lesser electrons it will allow to pass through it, and hence the lesser will be the amount of current. Going opposite, if the resistance is low, if the resistance is negligible, means they are easily permitting the electrons to pass through it. And if the electrons are easily passing through, that means the resistance is low, therefore the amount of current passing through this wire will be high or more. So now we can relate firstly what exactly is resistance. It is the opposing force of a substance to the flow of electrons, right? And this is how we are able to understand why resistance and current are inversely proportional to each other. If the resistance is more, then they will not allow electrons to pass through it, the amount of current will be less. And if the resistance is less, then the amount of current that can pass through it is more. Got it? Fine. Now, based on the resistances of various substances, the amount of current that they allow to pass through them, we categorize these substances into various categories. First of all, we call some substances as conductors or good conductors of electric current. Now, these good conductors, these conductors means that they conduct electricity. They conduct electricity means they allow the electric current to pass through them. Fine. And how do they allow or why do they allow? Because these good conductors have very low resistance. Since the resistance is low, therefore the current can easily pass through them, and therefore they are called good conductors of electricity. All the metals, these are all good conductors of electricity because they allow the electric current to pass through them because they have very low electrical resistance. Clear? There are certain substances which do not permit electrons to pass through them. Such substances are poor conductors of electricity and we call them insulators. They are bad conductors or poor conductors of electricity. Why they are poor conductor of electricity? Because they do not allow the current to pass through them, and because they are not allowing, they have a very high resistance, because of which the electrons are not allowed or permitted to pass through them, right? Now, there are certain substances which basically allow a partial flow of current. Those substances are known as semiconductors. Semi means half, half means partially. So, semiconductors are those substances which allow partial amount of current to pass through them. Fine. Some semiconductors are like silicon, like germanium. There are a few semiconductors which basically allow partial current to pass through them. Got it? A few metalloids which have the properties of both metals and non-metals. All the non-metals except graphite we have studied in chemistry, except graphite form of carbon, all the non-metals are basically poor conductors of electricity because they offer a high resistance, right? Plastics, glass, non-metals, wood, they all are poor conductors, bad conductors, insulators. Fine. So, this is what Ohm's law state, and this is what we have seen about the substances, conductor, insulators and semiconductors. Now, we will perform an activity to prove that current flowing through the circuit is different for different components. For this activity, we will be requiring the following material. First of all, we will be requiring a battery. Then we require an ammeter of range 10 amperes, a torch bulb, a 10-watt bulb, two 5 ohm nichrome wires, plug key and connecting wires. Now, let us start up the procedure, how we are going to proceed. First of all, we will try to have a setup by taking a battery consisting of 5 dry cells, a plug key, an ammeter of range 10 ampere and connect them all in series. Remove the key from the plug. So, now no current is flowing at the moment in this circuit. Now, what we will do is insert in the gap PQ a torch bulb and then insert the key. We will have a reading in the ammeter, read and record the current flowing in circuit and remove the key from the plug, right. While doing it, always remove the key from the plug after taking the reading from the ammeter, and in the table above, in case 1 we recorded the reading 2.5 amperes. Now, replace the torch bulb with 10-watt bulb and again repeat the above step. Again we will have a reading in the ammeter, we will note down the reading in our above table and again remove the plug key. Now, replace the 10-watt bulb with 5 ohm nichrome wire and again repeat the above step. Again we will have a reading in the ammeter, note down the reading in the table, right. Again take out the plug key. You observe that current flowing through the circuit is different for different components. Now, why does it differ? Obviously, certain electrical components offer an easy path to the passage of electric current while the others resist the flow. So, we have learned that electric current flows only in a conductor when the electrons start drifting from high potential to low potential. When the electrons start drifting, they mutually repel each other and also collide against the atoms of the conductor. This in turn gives rise to the opposition or obstruction of the flow of electrons. The opposition or obstruction offered by a conductor to the flow of the electrons is called the electrical resistance. Okay.